So for this one, you needed to graph this. It doesn't say how. So some of you may have started off with intercepts. However, if you started off with intercepts and you went to solve the x-intercept, you end up with some decimal or fraction. So in this case, if you end up with a decimal or fraction, unless it's a nice decimal or fraction like 0.25, 0.5, 0.75, something you could like accurately see where that would be, I would not graph this as intercepts. I would go back and I would convert it. So that means solve this equation for y, get y by itself. So we're going to subtract our 3x to the other side. I'm going to go ahead and switch these two so that my slope or my variable term comes first. And then divide everything by 4. And now that it's back in slope-intercept form, I can use that to graph. So I'm going to start at my y-intercept of positive 2. Let's do bright colors. And then we have a negative slope, so we're going to go what directions?
Down to the right.
Down and to the right. So down 3, 1, 2, 3, right 4, as many times as possible. And that's as far as we can go that way. What other directions would give us a negative slope? Go ahead, Sadie.
Up to the left.
Up, left. Yep. So we're going to go up 3 and left 4. As many times as possible. And that's as far as we can go. Again, if you need rulers, they're in the colorful cart. Grab them for your table. Make sure your lines are as accurate as possible. Go through all of your points and make sure your lines have arrows. Because lines go on forever and ever in both directions, its domain and range are all real numbers. Any questions on that? Some of you asked for the review. So remember that we've covered 3 topics: intercepts, finding them algebraically and graphically; slope, finding slope from a graph, from 2 points algebraically, from an equation algebraically; and then graphing lines from slope-intercept form and standard form, converting it from intercepts, and then horizontal and vertical lines. So we're going to go through those different things today, starting with number 1. To find the slope of this graph, this one has points, so we could start from those points and count how many units down and to the right or up and to the left. It is going to have a negative slope. Here we're going down 5 to the right 2, so our slope is negative 5 over 2. Make sure you're always going up or down first, and then left or right. Saeed?
Also just negative. Like the line.
You have to tell me exactly what it is. So negative would be partially correct. but negative what? I would need to know what the actual slope is. Other questions, concerns on number 1? What would the slope of number 2 be? You guys can say that out loud.
0.
0. If you need to go back, write your $4. Because that's going to help you with all of your horizontal and vertical lines from slope and graphing. What would your slope of number 3 be?
Undefined.
Undefined. So you can put U and D, you can spell out the word undefined, either or. Let's do number 4. So you'll need to remember and know the slope formula. So I'm going to go ahead and write it just so we all have it. Y2 minus Y1 all over X2 minus X1. You can write that in the same box somewhere where you have space, doesn't matter. If it helps you, label these X1, Y1, X2, Y2. Put all of your numbers in the formula. So this would be -4 minus -1 over -3 minus -12. You can either use your calculator, put this in all together, use your calculator, do this separately. Either or works. If you want to do everything by hand and maybe rewrite this first, you can do that. Remember, the negative and the minus come together, make a plus. So -4 plus 1 would give us -3. -3 plus 12 would give us 9. And then always simplify your slope answers. What would this simplify to?
-1/3.
Yes. And then make sure you're including equals m or m equals. I realized that when I made these review packets, I didn't include the slope problems with the fractions. So when we get to the end, we'll do one of those. I know you guys have some of those in your slope notes, so if you need more practice on that, you can go back to those. Questions or concerns on number 4? We're going to do number 7. Number 7 just asks us to identify the slope and y-intercept of this equation. So we need to know what is our m and what is our b. What is m? Yes. It seems like it's too easy of a question, but if you don't know which one is which, that will throw off your whole, like when you go to graph. What is the y-intercept?
0.
Is 0. So anytime it's not given there, there's an imaginary plus 0. Now for number 8, Could I say what the slope and y-intercept are right now?
No, you gotta have to put it in slope-intercept form.
Right.
Don't you say -2?
Yeah, so we're going to subtract 2x first. And I went ahead and I switched the variable term and constant term.
Then you divide 5.
By everything, yep. So now that it's back in slope-intercept form, what is our slope?
4.
For our slope is
-2.
-2/5. For our m. And then 4 is our b, our y-intercept. Do we have any questions on 7 or 8? Does anyone still need number 8 before we go to the next page? Number 12 and 13 are really writing equations of graph questions and not really graphing or slope questions, but matching the graph to the equation still helps you kind of determine slope and graphing. So remember that you'll have access to Desmos. If you were to get a question like this, what I would want you to do is put all of these in Desmos, see which one matches. So I know you guys don't have that right now. I would not use this on your calculator only because it's black and white, it's hard to see, you might miss or confuse it for something. Desmos have the color, so I would definitely use that. And I just put this down. So what I'm going to do is put all 4 of these in at the same time. Make sure they're all different colors. That way I can distinguish them each. And I'm going to type them in exactly as is. I feel like I mentioned this to you guys, that you don't have to solve it in Desmos. But if I didn't, I'm saying it now. Now you definitely could solve each one. It would just be a little time consuming. But you could do it that way as well. I'm going to go into this wrench and choose this. It's supposed to be like projector mode. It just makes the lines thicker, bigger, so you can see it more accurately. On the paper, what's your y-intercept of the graph? 4. So one of these has to go through your y-intercept of 4. Right now only 2 do, red and green. So I'm going to get rid of the purple and the blue. It has to be one of those. And then to figure out which one, count your slope. What is the slope of the line on your graph? Is it -1? -1/2. Which one of these has a slope of -1/2? 3. So that's a faster way to figure out which one matches. So we could circle, what was that, C, and say that's our answer. "13 would be very similar. Just put all of those into Desmos, see which one matches. Do we have questions about 12? We're going to do number 14. So remember when, or if you're given an equation, it doesn't matter if it's in slope-intercept form or standard form. If you're looking for intercepts, you're going to put 0 in for x, find y, put 0 in for y, find x. So I'm going to do one with actually putting 0 in, and then the other one where we assume we put 0 in and kind of skip a step. So if I put my 0 in for x, then I'm looking for my y-intercept. Let me erase that, that looks weird. This would give me just negative y equals 4, or just negative y equals 4. And I can divide both sides by negative 1. So y equals positive 4. What would that be as an ordered pair? What would your x be? 0. And then your y would be 4. If you know that that's what you're doing, putting 0 in for x or for y, you can skip both of these steps and just jump down to this one. Kind of like when we were covering up the term, seeing what's left, it's the same process.
What did it be negative for? Because you're dividing by
Oh yeah, my bad. I think I saw too many lines and thought it was already negative. So for your x-intercept, if you assume that I have to put 0 in for y, the y term becomes 0. So in a sense, this completely disappears. All that's left is 4x equals 4. I definitely have to do that in a different color. Then you could divide both sides by 4. And you get 1. What would that be as an ordered pair? 1, 0. We don't see it, but we put 0 in for y, and that's how we got this. Do you have any questions about that one? I'm going to do number 16 and 17. Is 16 going to be a horizontal or vertical line? Horizontal. At -2, so find where y is -2 on the y-axis, and draw a horizontal left and right line through that point. Not liking me either. Wow. And make sure your line has arrows. It's as straight as possible. And it's horizontal. If you made it vertical, that would not be a y equation, that would be an x. So 17 is going to be which type of line? Vertical. At 5, so find where x is 5 on the x-axis, and draw a vertical line through that. Oh, that does not want it to be straight. Alright guys, I have like OCD, and this bothers me. Well, that's not moving. Questions on either of those? Those are like the easiest ones on the graphing ones. Please do not mess those up. Do your Hoibucks if you need to. Don't assume know it for sure. On to the next page. We're going to do numbers 5 and 6. For number 5, it's asking about the slope of this line. Do I know what the slope is right now? No, why not? Because it's not in slope-intercept form. We have to completely solve this for y before we can assume what the slope is. So we can assume this is not 3 because it's not in slope-intercept form. So to get it in slope-intercept form, let's divide everything by 2. So our new equation would be y equals 3 over 2x plus 2. Now the 2 is here to confuse you if you aren't sure which one the slope is. That's why that's there. Don't make that mistake. That is your y-intercept, not your slope. And then the 2/3 is if you somehow mix up your slope. For number 6, we can do one of two things. It's asking which of these equations has a slope of 1/4 and a y-intercept of -2. We can convert each of these and see which one matches. Or we can put them in Desmos and see which one matches. That is completely up to you. I know you don't have Desmos right now. I'm going to put this in Desmos. But if you wanted to convert them, you could also do that. So just as I did these, I'm going to put all 4 in at the same time. So we need a y-intercept of -2. Right now it looks like they all go through that point of -2, so that doesn't really help us. We do need a slope of 1/4, so it has to be positive. So we can get rid of this red line because it has a negative slope, as well as the blue line because it has a negative slope. And focus on the black and green. Which of these have a slope of 1/4? The black one. Usually the steeper the line, the bigger the slope. The less steep a line is, the slope is usually a fraction. And you can count it. So here, there's another point that crosses these grid lines exactly. So from here to here, this would be up 1 over 4. So the black line, or the first option, would be our answer there. Yes, sorry.
Can you show how you can hold the egg?
So for A, we would subtract, you actually have two options here. For all of the problems I showed you, to move the x first, which we could still do, so I'm going to show you both ways. So we have negative 4y equals negative x plus 8. And then we could divide everything by negative 4. So we have y equals, this is really negative 1x, so this would be positive 1/4 x minus 2. That has a slope of 1/4 and a y-intercept of negative 2, so that matches. The other way you could do this is if instead of moving the x term, you move the y term. I know we have not done this, but it's a different way to kind of look at it. So if I move the y term over, I'm left with just an x equals, which right now that doesn't make any sense because we need it in y equals. But then I could move the 8 back. So this one's a little bit more work, because you have to move things twice. And then divide everything by 4. You still get that negative 2 and positive 1/4 x. It's just written backwards. Those are the same thing. That one would have more steps, but you could still do it that way. The only reason you would really do it that way is if you want to avoid dividing by a negative. So if you like it the first way, do that, and that's fine. Do we have other questions on those? On the next page, we're going to do 7 and 8. So this is kind of like the opposite of what we were just doing. Because before we were given a graph and had to match the equation. Now we're given an equation and have to match the graph. So for 7, it's asking which graph best represents this line, -1 shows x plus 2. Start eliminating some of them. Your y-intercept is 2. So if you don't have one with a y-intercept of 2, you can get rid of it. Unfortunately, all of these do. Then, look at your slope. It's negative. So if you have positive slopes, you can get rid of those. So like A and C. And then you're just looking at B and D. Which one of those has a -1/5 slope? B. And I could look at that and see here it goes through the grid lines exactly, so does here and here. If I count that, I'm going down 1 to the right 5, or up 1 to the left 5. So B would be my answer there. For 8, you could convert it and then do the same thing we did in 7, or you could put it in Desmos and see which graph matches. I'm going to convert this one. So we have negative y equals negative x plus 3. Divide everything by a negative 1. So y equals positive x minus 3. Which of these graphs can we eliminate based on the y-intercept? A and B. And then of C and D, which of these have a positive slope? C. C. I only have about 3 more that I want to go through with you. 2 are on the last page, and then 1 I'm going to give you. Do you have any questions on this page so far? We're going to do 12 and we're going to do 13. 12 is asking which of these have an x-intercept of negative 1. Notice that does not say y-intercept. It says x-intercept. And then it says y-intercept of 1. So that means you would either need to solve each of these to find your x and y-intercept, or use your calculator and Desmos to figure out which one works. I'm going to use Desmos because that would take less time. Some of them are easy enough to do that you could solve each one, but it's really your preference. If you want to do them algebraically, you definitely have that choice. So we need an x-intercept of negative 1. Right now there's only 1. So I can immediately get rid of everything else. I also need to make sure it has a y-intercept of 1, which it does. So I can get rid of these 3. So x minus y equals negative 1 has both an x-intercept of negative 1 and a y-intercept of 1. And then for 13, it's asking which lines have a y-intercept of 5. If it's in slope-intercept form already, you could easily see if it has a y-intercept of 5. So like, there's only 1 here. This one does not have a y-intercept of 5. Your b is not 5, so we can get rid of that one. This would be another example where you could solve each one. So I'm going to solve 2 of them and put the other 3 in this one. If I were looking at just the y-intercept, I just need to focus on this part. So I would divide both of these by negative 8. This would give me a positive 5. That would work. Again, I'm just looking at these 2, so I would divide both of these by a negative 1. But this one gives me a negative 5. So that would not work. Or you have the option to put all of them in Desmos at the same time, which is what I'm going to do for the last 3. So as I'm looking at these, I need all of these to have a y-intercept of 5. Only one does, so I can get rid of those two. So I can also check off the 6x plus 4y, but cross off the other two. Do we have any questions on any of the ones we've done so far? On the back of your review, I'm going to have you write this down. There's supposed to be space between the parentheses and the and. It just didn't happen that way. And this will be the last one we do, unless you guys have specific ones you want to go over. So remember, don't freak out if you get these. It's the same process, just take it a little bit slower. You do have the option to use your calculator / Desmos, but I do need to see how you set it up. So setting this up, I would have -2/3 minus 3/4 all over 3/4 minus a -2/3. Or if you change that to a plus in the denominator, that would also be fine. If you put that all in your calculator, remember to do it one at a time. Do this part, then divide them at the end. I'm going to do it by hand and then do it in the calculator. So by hand, we would need to get common denominators for everything. What would a common denominator for these be? 12. I need to multiply this by 3 and this by 4. And then same thing in the denominator, multiply this by 3 and this by 4. Really quickly, before I do that, I'm going to change this bottom part so that it's plus. That way I don't have to worry about it later. You can still keep going though. So all of your new fractions would become -8/12 minus 9/12 all over 9/12 plus 8/12. When we combine our fractions, -8 minus 9 would give us -17. And 9 plus 8 would give us a positive 17. And then we don't like fractions within fractions, so to get rid of this, we're going to multiply by the reciprocal. But what happens is, because it's the reciprocal of itself, this cancels and becomes 1. This cancels and becomes -1. -1 over 1 is just -1. So we have all those fractions, but it just became a whole number. Sometimes that happens. Before we do it in the calculator, does anyone have questions on that process? How we got the answer? Aubrey?
Can we do one when we get fractions?
We can make up one, sure. Let me do this one in the calculator and then sure. Yes.
How did it turn plus?
Yeah, which part, sorry? Right here.
Yeah.
So anytime you have a negative and a minus, they come together to make a plus. Great. Let's do this in the calculator and then we can make up one. So we would start with our fractions that we got at the beginning. We're going to do this part, -2 over 3 minus 3 over 4. To get your fraction, alpha y equals -2 over 3 minus 3 over 4. Then we're going to do our denominator, which was 3 over 4 minus a -2 over 3. Then I'm going to go up to the top for the first one. Grab that one. Hit my division button. Go up to the other one. Make sure it's highlighted. Hit enter. And hit enter again. I would not put all of this in at the same time, only because you would have to put in so many fractions and things might get messy. There's no guarantee that when you make up these fractions, they're going to equal a fraction, but so this is if you would like to practice this one again, or practice a slope with fractions again. Someone give me a fraction.
5 over 8.
Okay. And another fraction. What did you say? And then 2 other fractions, preferably not the same ones. So you go.
4 over 3.
Sure. One more fraction. 2 over 4. So 1/2. Okay, so I don't know what the answer to this is. We're going to work this together. We're actually going to do some of this in the calculator, but if you wanted to do it by hand, you are definitely welcome to do that. So setting this up, this would be, I definitely just extended this page. 1/2 minus 2/3 all over 4/3 minus 5/8. I'm going to put all of this strictly in the calculator, just because my brain is slowly frying. You could definitely do this by hand and see if you get the same answer. this is not going to be next. Take this and divide it by this. What's nice about your calculator when you put these in is that whatever it is, it simplifies it for you. So the slope for this, after doing all of the work, if you did it by hand, would be -4/17. I don't think I wrote that for. Oh yeah, I did. So if you were doing it in the calculator, that's really all I would need to see. That you set it up, and then you can put it in your calculator. Yes, second.
Then we would just write down the calculator.
Yes. Did we have any questions that I skipped that we want to go over? Aubrey.
Number 9 on page 1.
This is going to be similar, so you would need to convert it. When you divide, this would be +1/2 x and then -1. So what would your slope of that be?
1/2.
1/2. And the y-intercept? -1. Other questions that I skipped that we want to go through? For the fraction ones, if you don't want to go back to your slope packet for those additional ones, I see your hand. Hold on one second. You could do exactly what we just did, make up 4 random fractions and go through the process. I can check it if you do that. Just give me a second because I have to do it myself. Athena? Is that this? Page it first. Okay, number 3. Yeah. Number 3, what is the slope of the line that contains these points? So we would have to do the same thing, do that formula to figure out that answer. -4 minus 1 over 4 minus a -6, or -4 minus 1 over 4 plus 6. -4 minus 1 would give us -5. 4 plus 6 would give us 10. What would this simplify to? -1/2. So D would be our answer. Any other questions before I let you practice for the rest of the class? So you have the rest of this review packet. You can go through as many of those that you need or want to practice. If you have missing Khan Academy's or Delta Math that you would like to use to practice, you can go through those. But you should be working on one of those things. Let me know if you have any questions or want me to check something. And then if you have any review questions that maybe I don't get to or get around to you, bring those to class on Monday and we'll go through any last minute review questions. Anyone have any questions on what we're doing for the rest of the class? You guys have this time to work?